know about you, but some mornings I wake up and I read the news. I look outside of the world. I read the headlines in particular, and I get the sense that the world is going crazy. This is my world has gone mad slide. I picked this slide because it embodies a lot of the features that I think we see in the world today. We see a great deal of change, and we see a great deal of chaos, and yet we also see possibilities for growth and creativity and self-expression. It's a kind of paradoxical period, a kind of chaotic, confusing period. And most of the time when I talk to young people and I ask them what they think about the world today, they tell me that they think the world has just gone off its axis, that we've all gone mad. The Dalai Lama summed it up by talking about the paradox of our age. He said, we have bigger houses but smaller families. He said, we've been all the way to the moon and back, but we have trouble crossing the street to meet the new neighbor. He said, it's a time when there is much in the window, but nothing in the room. And I think that kind of sums up the paradox of the world as we see it. It might interest you to know, though, that some 50 years ago, a microbiologist named Jonas Salk predicted that the period in which we're currently living, this period of apparent chaos and confusion, would in fact come into being. Now, at the time, I, at the ripe old age of 24, thought that the world was pretty chaotic enough then, but he said, oh, hold on, it's going to get much crazier. We're going to see far more conflict, chaos, and opportunity for important social change. Now, if you'd been born when I was, you'd know very well who Jonas Salk was, but these days I'm discovering that millennials don't recognize his name. He was catapulted into international fame back in 1955 when he discovered the first safe and effective vaccine for the prevention of polio. Polio was a disease that had been around at least since the time of the pharaohs. It was a crippling, sometimes fatal disease, a viral disease which spread very rapidly in the population and particularly spread to children. That said, President Franklin Delano Roosevelt suffered from polio, nearly died from it, and did spend his presidency and the rest of his life in a wheelchair because of it. Polio was a terrifying disease, and in the warmer months of the summer, people lived in terror that a simple sore throat or fever might be the beginning signs of polio and could be indicative of a terrible life ahead or even a fatal outcome. After he developed the vaccine, he was literally thrust into international fame. Newspapers all over the world spread the word very rapidly that a vaccine had finally been found. He got all kinds of impressive awards. He won the Presidential Citation from President Dwight Eisenhower, and then later the Medal of Freedom from President Jimmy Carter. 5 years after the vaccine came out, Dr. Salk moved to California. The city of San Diego gave him this beautiful piece of property right on a bluff overlooking the Pacific in La Jolla, and he founded the Salk Institute for Biological Studies. This is another picture of it, which shows what it looks like at sunset each day, or most days. About 10 years after the Salk Institute was founded, I came to know and work with Dr. Salk. I was really just thinking that I would spend 1 year out of graduate study working with him in a field that he called metabiology. Now, he was a biologist by training, but through most of his life, certainly through his entire adult life, he was convinced that the most serious threats to human life and survival were not biological threats. He believed that we were far more likely to succumb to forces at work in our psychological and social natures than to biological antigens that might affect us. So even though he chose to pursue a career as a biologist, as a researcher, as a person who developed vaccines and medical treatments, he felt that we needed to spend much more time considering human nature and the possibilities that elements in our own nature need some careful reconsideration. Now, about the time I went to work with him, there were a number of people who were proposing that the end of the world was right around the corner. There was one book that became a bestseller very rapidly by a guy named Alvin Toffler. He wrote a book called Future Shock, and he said the pace of change these days is so rapid that we simply can't keep up with it. We can't adapt to our world. Change has become a toxic feature in modern life. Another author, a biologist like Salk, Paul Ehrlich, wrote a book that also attracted a great deal of attention called The Population Bomb. And in that book, he suggested that as a result of the rapid increase in the size of the human population, we were headed for oblivion. He went and revisited the theory that Thomas Malthus had proposed that suggested that when populations grow sufficiently large, the natural outcome is a spreading of disease, increase in hostility among people, environmental degradation. Essentially, the world will self-destruct when populations become too large. The graph here is a graph that shows human population growth, and you can see, if you look at the red lines there, you can see why there would be some alarm about the rate of our population growth. You can see from this graph that for several millennia, or for that matter for all of our history as a species on the planet, our population did not really grow very much at all. We had a small and relatively stable population. We begin to see an increase in the size of the population about 2 millennia ago. But even then, it's a fairly gradual increase until we reach around 1750. And from 1750 forward, we see exponential population growth. Now, here is a chart showing you what exponential growth looks like. These are paramecia, and in the first slide you see on day 0, 1 paramecium in a closed system. But by day 6, the population size has grown much larger. 1 becomes 2, and 2 becomes 4, and 4 becomes 8, 8 becomes 16, 16 becomes, you see the point. So very rapidly, when you have exponential population growth, it takes very little time for a population to grow extremely large and possibly too large to be sustained given the environment. Here's another way of looking at how our population has grown over history. It took us 300,000 approximately 300,000 years to reach the year 1800 and have 1 billion people on the planet. It took from there another 127 years to get us to 2 billion. From there, it took only 33 years to get us to 3 billion. As you can see, the number of years between our adding another billion gets smaller and smaller over time. So we went from 5 to 6 billion people on the planet in 12 years, which is alarming. You can see why, if we were to continue at that rate, we would naturally be terribly overpopulated. The end result then would be, as Malthus proposed, spreading disease, increasing social conflict, possibly war, environmental damage, degradation, pollution. Not a very pretty picture. So at the time I went to work with Dr. Salk, it was fairly common for people to be assuming that we were on a fast track to global destruction. People were typically proposing that the end was indeed very near. Well, Salk then wrote a book where he proposed an alternative way of looking at the prospects for our future as a species. He presented what he called a metabiological theory. It was a theory derived from his understanding of the operation of biological systems, and it took knowledge of biological systems and applied it to human social systems. The theory proposes another and perhaps more hopeful way to look at the way we might proceed into the future as a species. Essentially, the beginnings of the theory came in 1925 when a biologist named Raymond Pearl ran an experiment in which he discovered that if you take fruit flies and you put them in a closed system, they will reproduce according to a particular pattern which is called a sigmoid growth pattern. They will, in the beginning, reproduce at a very rapid, and in fact an increasingly rapid rate, until at some key point toward the center of that curve they start to slow down, and during the second portion of the curve the rate of growth is increasingly slow, if that makes sense, until they reach a point where their population growth levels off, their birth rate and their death rate is equal. Now, Raymond Pearl only looked at fruit flies. Jonas Salk decided to see whether that same pattern was evident in other living systems. And what he discovered is that it is in fact everywhere. If you take amoeba and put them in a closed system and let them reproduce, they will follow a sigmoid growth pattern. If you take two guppies and put them in a fish tank, they will produce many more guppies, but they will follow a sigmoid growth pattern. Same thing with sheep. Take two sheep, put them in a meadow, have a fence around their living area, and let them reproduce naturally. Over time, they will produce more sheep, but they will also conform to a sigmoid growth pattern. Same thing with doves in an aviary. They will reproduce to make many more doves in an aviary, but the interesting thing is that they don't overpopulate the environment. They follow a sigmoid pattern so that their population size levels off at a certain point, and they don't overpopulate in the way that some social scientists had been predicting would happen to the human species. At the time I was working with Salk, I said, you know, I can see that this pattern is everywhere, but I'm guessing that it doesn't also exist in cancer cells, because after all, cancer cells don't have the normal growth control mechanisms that normal cells have. So, and at first he agreed with me, and then we did some more checking, and sure enough, cancer cells also grow in a host according to a sigmoid growth pattern. So even cancer cells in a host will follow a sigmoid growth pattern. In other words, the sigmoid growth pattern seems to be nature's signature, if you will. It's everywhere in nature. Organisms that follow a sigmoid growth curve are apparently doing so because it is a pattern that allows them to reach but not exceed optimal numbers, given the conditions in the environment, given the availability of natural resources they have at their disposal. Now, it took us some time to figure any organism that didn't follow a sigmoid growth pattern, but in fact, for every rule, you can usually find an exception. And in this case, the exception we found was the lemming. Lemmings have been thought to be suicidal animals, but in fact, they're probably not suicidal, but they also don't follow a sigmoid growth pattern. They're cute little rodents that live in various parts of the world, but the Norwegian lemming in particular doesn't follow a sigmoid growth pattern. What happens with the lemming is that it undergoes extremely rapid population growth, and then it goes on a normal migratory path that leads it toward a cliff, and it goes quickly into the Atlantic Ocean where it dies. It's easy to see why we thought that these were suicidal animals. In fact, their mass deaths were the result of a not so good choice in migration. But at any rate, what you would see with them is a growth curve that looks like a J. You see very, very rapid population growth, and then you see this sudden loss of population. And what then remains are the very few that didn't go over the edge of the cliff and die. So the question then remains for us as a species, if you go back and look at our path, our population pattern, the question is, given the rapid rate of growth that we have followed since the 18th century, are we going to follow a pattern like the lemmings, or could we in fact follow a sigmoid pattern, in which case our curve would look something like this? In fact, if we were going to follow a sigmoid pattern, we would have to see some pretty dramatic changes happening across the planet, certainly with regard to population growth, that would give rise to substantial slowing down of the size of our population. Salk said then, if in fact we have the potential to follow a sigmoid growth pattern, what does that mean? What are the implications of our following that course? So he stepped back and looked at the sigmoid curve itself. And he noted that the curve can be broken down into two segments. The two segments are mirror images of each other. They are exact opposites, if you will, in the sigmoid curve. Now, if we assume then that this is a curve that unfolds over time, then we could say that the population would be moving from one epoch, which he called epoch A, into a second epoch, which he called epoch B. What would the values systems, what would the world look like in epoch A? Well, we can look back historically to get a sense of what epoch A has been all about. Epoch A values, he said, are values that focus on survival of the fittest, which is a competitive strategy. It's a competitive means whereby organisms presumably adapt and become fitter over time to an environment. Epoch A was a period where our focus was on fighting disease. We weren't concerned so much about preventing disease as we were in fighting disease. Epoch A was a period where we saw tremendous technological growth and development, and we saw a spread of capitalism across the planet, and it literally happened all over the globe. And with that came values for having things bigger and better and more comfortable and faster and cleaner and all that good stuff. We had values that suggested that more is merrier. Through much of our history, having more children was not a negative thing. Certainly through our agrarian history, having large families was a positive. Well, if those are the kinds of values that would dominate in Epoch A, what can we assume would happen in Epoch B if Epoch B is the mirror image of Epoch A? And what he proposed was that we would see a shift from competitive values to cooperative values. He said that instead of trying to cure diseases that have been making us sick, killing us, crippling us, we will focus on trying to prevent diseases in the first place. We'll see preventative health measures becoming more popular. We'll see people more concerned about eating healthy food and living a healthy lifestyle. We will see more concern for quality rather than quantity. So the notion that small can be beautiful will become a more popular notion, and in general we'll be looking for less stuff but better quality stuff in our lives if we are in fact going to move into a period when the values that were dominant before are flipped over into a new set of values. What that suggests then is that where we are at the present time would be, we are standing at the point of inflection on this curve. Now, I began by saying that Salk proposed that we were headed for some really crazy times. He said that the world would seem like it was gone mad. And the reason is that at the point of inflection, what you start to see is a great deal of antagonism between Epoch A and Epoch B values. People who are proponents of Epoch A values are going to be at war, so to speak, with Epoch B people who are trying to move their values forward. So essentially, we would see increasing polarity at the point of inflection on the sigmoid curve. Incidentally, Salk thought that the people who will understand this way of looking at the world and who will be the carriers of Epoch B values are much more likely to be the young rather than the old, that they will have grown up at a time where they will be particularly sensitive to the problems that are inherent in continuing with the competitive strategies that have prevailed during Epoch A, and they will be more likely to be pacifists. They will be more likely open to competitive ways of solving, or not competitive, but cooperative ways of solving problems. He was very, very much focused on the idea that the younger generation will be able to lead the way into a new epoch which will allow us to survive. So the key questions that we face at this time, when we are right in this ever so turbulent period, is can we as a species find ways to replace the competitive values that were the Epoch A values that served us very well to get us where we are now? Can we replace those values with cooperative Epoch B values that are what would be needed to carry us into the future? If we use the sigmoid curve as a guide, can we see that what worked in the past to allow us to develop technology and medicine and science that allowed us to change the very nature and shape of our planet are forces and features that will not serve us in the future? Can we understand that what was positive in the past may not have positive value in the future, and that a new set of values need to come into being? Essentially, to sum it all up, he pointed out that when the animal on the planet who's at the top of the food chain is manned with thermonuclear weapons, it seems fairly obvious that cooperative means of solving problems are our best hope for survival. Now these days, as we listen to the news and hear threats going back and forth about bombing happening here or there on the planet, this way of thinking seems to make a lot of sense. The idea that, yes, we have the power to destroy the entire planet, but is that really a wise way forward? Is that really the way we should be thinking, the way we should be going if we want to continue as a viable species? There is some evidence already to suggest that the theory that Salk was proposing is in fact coming into being. If you look at this chart here, we're showing that there has been evidence that the population has been slowing down its growth rate and doing so in a pretty substantial way. You'll notice that if it took us 12 years to go from 7 billion to 9 billion, it took us 14 years, or will take us 14 years to go to 10 billion, or I'm sorry, to 9 billion, and then 18 to go to 10 billion, and then 33 to go to 11 billion. So it's the pattern is changing such that we are slowing down the growth rate. Here's another graph that shows that more clearly. This shows population growth from 1950 to 2050, and you can see that it's clearly on a decline. This is another one that shows pretty clearly what's happening, although it breaks it down by parts of the world. And you can see that in general, the trajectory for the overall world population is that it should be slowing down and beginning to level off. Now you can also see from this where some of the regions in the world are where we don't see as much decline in population growth. Africa in particular has continued to show fairly rapid population growth, whereas other parts of the world that have undergone industrialization have slowed their population growth down quite substantially. I know that in several recent years we've seen 0 or less than 0 negative population growth in the United States, in other industrialized countries. And the overall effect of that on the global population is to slow the pace down. The question then is, can we adopt the kinds of cooperative social systems, philosophies, strategies that will allow us to avoid overpopulation, environmental destruction, massive spreading of disease? Can we evolve into a new epoch with a new set of values? Whenever I ask this question in my classes, I often find students say, we're just too competitive a species to do that. People say, it's just in our nature to want to fight, to want to compete with our neighbor, to want to outdo the neighboring country. It's in our nature to want to build walls and not bridges. And when I hear that, I have to say that if you look back historically into human history and you go back further into the history of our species, you find that for 99% of our history, we were nomadic, hunting and food gathering people whose primary strategies were not competitive, they were cooperative. We had rules of reciprocity that worked very well to ensure that individuals in a band were more likely to survive because they had mutual support of other members of the band. So my answer to the argument that we are just too competitive to ever change gears to becoming more cooperative is that we do know how to be cooperative. For 99% of our history, that was how we behaved. It's only been in the past few hundred years that we have become so fiercely competitive. So if you go back in history, there's plenty of evidence that we are capable of cooperative strategies. The question really is, in our highly complex world, in our world of nation states, are we able to take the things that we understood about cooperative interaction when we were hunting and food gathering nomads and translate them into this ever so much more complex world scene? That is the question of the day. I think we are capable of it, but it is something that has to be, I think, brought more into our schools and into our ways of thinking about who we are and how we want to go forward. So essentially, we could be at the end of Epoch A, but the dawning of Epoch B.
Thank you so much.
Thank you.